In order to use congruent triangles, we first need to look at CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. CPCTC says this: after two triangles have been proved congruent, all the remaining parts are congruent. CPCTC gives us a way to use congruent triangles to prove something else. Let's look at a proof where we have to use CPCTC. In this proof, we need to prove that MS is parallel to TR. To prove that lines are parallel, we need to use angles, and when we have congruent angles, we can say that the lines are parallel. If we look at this drawing, angle M and angle T are alternate interior angles, as are angle S and angle R. If we can prove that angle M is congruent to angle T, or angle S is congruent to angle R, then by the alternate interior angles converse, these two lines will be parallel. So ultimately, that's what I want to show in my proof, that either angle S is congruent to angle R, or angle M is congruent to angle T. Either one of those will give me parallel lines. So the whole idea of this proof is to get these angles or these angles congruent to each other. Well, if I look, those two angles are parts of two triangles. If I can prove that these triangles are congruent, then by CPCTC these angles will be congruent, which shows that my lines are parallel. So I need to use these givens to prove that my triangles are congruent. If I look at my first given, A is the midpoint of MT. Well, if A is the midpoint of MT, that tells me that MA is going to be congruent to AT by the definition of a midpoint. And if A is the midpoint of SR, then A has to be in the middle of SR, meaning that SA has to be congruent to AR by the definition of midpoint. So between these two triangles, I have a pair of congruent sides and a second pair of congruent sides. I need one more piece of information. Well, if I look at the way that the triangles are drawn, I have vertical angles. This angle is vertical to this angle, and by the vertical angles theorem, those two angles will be congruent. I also know that angle MAS is going to be congruent to angle TAR by the vertical angles theorem. So if I look at this information, I have three pairs of congruent parts: side, angle, side. So these three things will combine to prove that my triangles are congruent. Triangle MAS is congruent to triangle TAR. All three of those parts prove that my triangles are congruent, and then by CPCTC, these angles will be congruent. That's the flow of my proof. I need to write my proof. Statement 1 is my first given. A is the midpoint of MT. By the definition of a midpoint, A has to be in the middle of MT, which means that AM has to be congruent to AT. I'm going to mark that congruent in my triangles. That's the definition of midpoint. That gives me my first pair of congruent sides. Now I'm going to prove these triangles congruent by SAS, so I'm going to write my proof to flow that way. I'm going to hop to my congruent angles. Angle MAS is congruent to angle TAR by the vertical angles theorem. Notice that I had to name these two angles with 3 letters. Whenever I have a vertex with multiple angles around it, I need to use 3 letters to name that angle. Now I'm going to go to my other side. To get my other pair of congruent sides congruent, I need my second given. A is the midpoint of SR. Since A is the midpoint of SR, SA has to be congruent to AR. I'm going to mark those segments congruent. So these two triangles are congruent by side, angle, side. So I'm going to state that. Triangle MAS is congruent to triangle TAR by side, angle, side. Now it's only after my triangles have been proved congruent that I can use CPCTC. After my triangles have been proved congruent, which I've done in these 6 steps, all the remaining parts are congruent to each other. So if I look at my triangles, MS will be congruent to TR, and angle M will be congruent to angle T, and angle S will be congruent to angle R. Well, I need to pick the piece of information that will prove that my line segments are parallel. So I want to pick one of these pairs of angles. It doesn't make a difference. I'm just going to pick one. I'm going to say that angle S is congruent to angle R. If you look, they're corresponding parts of congruent triangles. Now be careful. A lot of you will want to say that angle S and angle R are congruent because they're alternate interior angles. That's not the reason they're congruent. They're congruent because they're parts of corresponding congruent angles. And because they're congruent, that proves that my lines are parallel. Whenever I have alternate interior angles that are congruent, the lines cut by that transversal will be parallel. Notice a couple things. I didn't use CPCTC until after my triangles are congruent. I can never use this until I've stated that triangles are congruent. And the reason that these two angles are congruent is not because they're alternate interior angles. They happen to be alternate interior angles that are congruent by a different reason. Let's look at a second proof. In this proof, I'm trying to prove that CM is congruent to MD. Well, if I look just right, CM and MD are parts of 2 different triangles. I'm going to draw in those two triangles. And between those two triangles, I have a pair of shared sides. So I know that MB is going to be congruent to MB. So automatically between these two triangles I have a pair of congruent sides. But I need more than that. I have another pair of congruent sides, CB and DB. That's in my givens. So I need one more piece of information. Well, I can't use CM and MD being congruent to each other. That's what I'm trying to prove. So I need another piece of information. Namely, I need this angle to be congruent to this angle. And if I look, those two angles are parts of these bigger triangles. And if I can get these bigger triangles congruent to each other, then that'll be enough to prove that these smaller triangles are congruent to each other, which means that these two segments will be congruent to each other. So that's the flow of my proof. Step 1, get these big triangles congruent to each other. Then, using the parts of those big triangles, get these smaller triangles congruent to each other. Then by CP/CTC, these segments will be congruent to each other. So let's write a proof that does that. These big triangles will be congruent by side, that's a given. Side, that's another given. Side, they share a side. So that's step 1 of my proof. I can use that given because AC is congruent to AD. CB is congruent to DB. That's a second given. Both of those give me pairs of congruent sides for my green triangles. Now I need a third pair of congruent sides. Well, that third pair of congruent sides is going to be that shared side, AB. So my two green triangles will be congruent by side, side, side. Triangle ACB is congruent to triangle ADB by side, side, side. So now that these two green triangles are congruent to each other, all their corresponding parts are congruent to each other. And the parts that I want are this angle and this angle. So I'm going to use that. Angle CBA will be congruent to angle DBA by CPC/TC. Now if you look, these two angles will be congruent. These two sides are already congruent to each other. Now I need BMB to be congruent to itself. So if I look, to prove that these smaller red triangles are congruent, I'm going to use side, angle, side. Side, angle, side. CB is congruent to DB. Well, I've already said that. I can use that in my proof. CBA is congruent to angle DBA. I got that after proving my big triangles congruent to each other. And MB is congruent to itself. So now I know that triangle CBM is congruent to triangle DBM by side, angle, side. And by CPC/TC, CM will be congruent to MD.